Hello, students. Hitting 12.2 homework, we've got 1, 3 through 9, 13, 15, and 21. So not a ton of homework on this section. It's a shorter section. So let's tackle it. 1 and then 3 through 9. So again, here, you are going to do a little bit with construction. And it does say you can use a protractor and a measuring ruler. This is not the same as a compass and a straight edge. So that means you can actually measure a 60-degree angle and you can measure a 70-degree angle, and then you can create your shape. All right. So that's what we're looking to do. And let's see here, triangle with angles measuring 60, 70, and a non-included side of 8 centimeters. So just so we're on the same page, when it says, and I'm in part A, but it's going to be the same for part B. I'll answer this question in part A, and then we'll move on. But when it says 60, 70, and a non-included side of 8, then when you build your angle that's 60 degrees, right? And you come over here and wherever you go and you build a 70-degree angle, you need this length right here to be 8 centimeters. Don't put it between the two of them. This would be wrong. You need it to be not included when it says this. For the first one, part A, it actually says, and an included side. For that one, the 8 centimeters would be between the two. Okay. And again, take a look at the directions. It just says draw if possible. So it may not be possible for some of these to actually work. Triominoes. I don't know. My grandma used to have this game at her house. It was like dominoes, but it was called triominoes. So anyway, let's see here. Okay, same type of thing. You're going to build a right angle with one angle of 75, so a 90 and a 75, and one leg of 5 centimeters, and have that leg be on the side of the 75-degree angle. Build a triangle with a 30, 60, 90 if possible. Again, all of these are if possible. Next up, questions 3 through 9. Let's see here. So once again, similar to 12.1, I'll give you two triangles. I will see if what I tell you here is enough to prove that the triangles are congruent. If it is enough, make sure you say why. Angle, angle, side, side, angle, side. Any of the pieces that we know work will be just fine. Let's see here in the figure. Okay, so K and L are two lines. And A, B, and CD are perpendicular. Okay. Why is quadrilateral A, B, D, C a rectangle? So go back if you need to, go to that definitions page. What is a rectangle? A rectangle is a parallelogram with one right angle. So right now you can see it's got one right angle, but you'd need to show that it is a parallelogram. Okay. What does that mean? You'd have to show that K is parallel to L, and then you'd also have to show that AB is parallel to CD. Okay. So that's what you're looking to do. And I think you have the tools right here because of what we learned in section 11.2 and 11.3 with the parallel lines being cut by a transversal. Question 5, list congruent triangles if there are any for each of the following. If they're congruent, say why. So again, this is a good opportunity to see visually what makes these triangles congruent or not. Let's see here. Given these triangles and they give you these congruent pieces as shown, what else do you need to show congruence? There might be multiple answers here. There should be multiple answers. So your goal is to see what else do I possibly need that would guarantee that these two shapes have to be congruent. Okay. Let's see here. Given circle O, find each numbered angle. Oh, this is a great one. Just remember, this is a circle. And D is the center of the circle. They didn't say that explicitly, but that's what they meant to say. They meant to say D is the center of the circle. Given circle O. Yeah, they meant it is a circle, yes, but the center is D. Right? And you'll need that because the center to the outside edge is the same. So you get these radial measures. Let's see here. Question 8 in the figure below. We have two parallel lines. Make sure you mark them. That's my tip as well as you go through this. Notice they didn't say all the lines are parallel. They said PQ is parallel to RS. So PQ is parallel to RS. Got it. Okay. And angle P is congruent to angle R. Got it. Now you look at what you have to prove. You have to convincingly tell me why PQ is the same as RS. Why are those the same? Okay, there should be a reason why. All you have to go on are what is given to you and all of the truths that you know that we've either proved to this point or that you can demonstrate. And likewise, we have isosceles triangles. From what you see in these isosceles triangles, your goal is to prove that the two triangles are congruent. And I should note, when they give you a symbol like this on the side with one tick mark, those two pieces are the same. And because it's the same problem, one tick mark also means that the other pieces are the same. Okay. That is good to know. Let's see here. What else do we have? What did I say? Well, 3 through 9, then 13, 15, and 21. So not that many after this. 13, nope. Oh, and if you look in the homework, you'll see questions like, this figure is a trapezoid. They'll tell me some conditions. Prove that if the sides are the same, then the angles have to be the same. So that's kind of the prove that if you have a trapezoid with these conditions, that it is an isosceles trapezoid. Okay. And let's see here. Oh, I know I put these together. These are the always, sometimes, never. It's like practice getting yourself ready for the test. And again, make sure if it's false, give me a counterexample. If it's like, hey, sometimes that's true, and you can see some, they'll even say it here. They'll say no rectangle is a rhombus. So on the test, I would say a rectangle is a rhombus, and then you would say always, sometimes, or never. Okay, so that's 13. Is that it? 15 and 21. So 15, here we have a concave kite, and angle BAD is RBAD and BCD congruent. Oh, okay. And then you have to be able to justify why. So if you're trying to show congruent angles and you don't know anything else, build triangles that are congruent, right? Let's see here. A, B, C, D, E, F is a hexagon, but I don't think I assigned that one. I think the next one's just 21. Yeah. 20. Okay. Suppose polygon ABCD is any parallelogram. Okay, so this is a parallelogram. And then what? The questions on the next page? Ugh. This, I did assign this one on purpose because I tend to give a question similar to this on exams. The goal is for me to tell you something about it, and you have to prove. So I could give you that it's a parallelogram. You prove the opposite angles are congruent. I tell you it's a parallelogram. You prove the opposite sides are congruent, and vice versa. If I tell you here's the shape and the opposite sides are congruent, you should be able to tell me that it is a parallelogram. All right. All right. I think that does it for the homework. Awesome. All right. Bring questions to me. I can meet you in Zoom. I can do a recording for you. I can meet you on campus. Let me know what you need. I'm here to support you. All right. Off you go.